All right, here's our second review. So we'll work through this. A runner in a race ran quickly for the first few minutes, slowed down some, and then ran a steady race. Okay, so we have a few things happening. Ran quickly, slowed down, ran a steady pace, and then ran as fast as he could at the very end. So choose the graph that best describes this. Ran quickly. Okay, they both are running quickly. Then slowed down. Okay, so far right away I'm saying graph A because this one stayed the same. Let's make sure the rest works. Slowed down, ran a steady pace, ran as fast as he could. How'd you like that sound effect? Good. Next, we've got dog food. Dog food is sold in 7-pound bags. Can we go in the store and rip the bags apart and take 1 pound out instead? No, we cannot. So right away I see that discrete jumping off the page at me. It is discrete. I don't have to read anymore. Sketch a graph to show the weight of dog food purchased by a customer who buys 0, 1, 2, 3, or 4 bags. Tell whether the graph is this. So I underlined them to make sure I don't miss. Sometimes people miss that first one. So there's 1, 2, 3, 4, 5 different things. So if we bought 0 bags, how much food? Obviously 0. If I bought 1 bag, how much food? 7 pounds, right? So that's like right there. And if I bought 2 bags, 14. 3 bags, 21. 4 bags, 28. Right there. Done. We do not connect it because it is discrete. We cannot do 1.5 bags. No can do. Not in this world. And the next one, express the relationship, the mapping. Again, I'm hoping you're getting good at these. The x's go over here and the y's here. So I got -2, 2, and -3. Okay. I'm going to go in increasing order because it's organized. I don't think you quite have to, but it'd be nice. And the y's, 3, 4, and 4. And as I said, you do not have to list the 4 twice. You don't have to repeat it. Increasing order. -2 to 3. 2 to 4. And -3 to 4. All right, when we look over here, the range. That's our y values. So we're going to set it up. I have a graph. This is a continuous graph because it's not just a few select points. It's a continuous going in a circle. And I'm now going to use my little thing here. And if I want y values, how am I going to hold this? This way, right? It's going to have to go through the y so I can see what number. Right, this way. So I'm going to start at the lowest and go up until I hit and go boom. It hits at the 0. Keeps going until it hits the what? Trying to line it up with the camera here. Till it hits 4. So 0 is my small number and 4 is my bigger number, and you can try to put those cool brackets around it. Now we jump to domain. That's x values. Is this continuous or discrete? Definitely discrete. I have specific values. So I'm going to list the x values, -1, -0.5, 0, and 0.5. And we are done. I don't need to worry about the y's. If I asked for both, you would be clear to label that as domain, and then you would list your range to, you don't need to list it twice. 2, 5, and 6 would be all you needed. Tell whether the function is a relation. So I've always said, when you're doing these, just look at your x's. If they're all different, it's just easy street. Are they? Yep. So yes, It is a function. Every x maps to 1 y. Or goes to 1 y. Or you don't have to use the word maps, but. Okay, number 7. Which equation shows the relationship between x and y? Okay, so you basically have your x values and your y values. I'm going to organize them this way. 1, -3, 2, -1, and 3, 1. So I can just kind of see them systematically. Sometimes when they're listed this way, it's harder to see. You can punch them all into these and see which one works. That's probably going to be your easiest bet. I'm going to start with the positive ones because it's a little simpler. And once I find one that works, I can check the others. So let's try A here. Let's start with there. So y is 1. So I'll put 1 in there, and x is 3. And see if it works. 1 equals 2 times 3 is 6 minus 5. 1 equals 1. Hey, that works. Okay, well, let's try the other ones. What if we put these in? So let me try it down here. Put in the -1 for the y. Put the 2 in for the x. And check that out. -1 equals 4 minus 5. -1 equals -1. I'm off the screen. Yes, it works. One more to go. We got to check the top one. Y equals 2x minus 5. -3 equals 2 times 1 minus 5. 2 times 1 is 2 minus 5. Yay! That was nice. It worked right away. But sometimes what will happen is if you put the y in, like for this one, and put the 3 in for this one, 3 minus 4 is a -1. That's not equal to 1. So that rules that one out right away. You know, if you put a 1 in for the y here, is that equal to 2 times 3? No, rules that one out. So sometimes it's easy to rule them out because right away you get a negative, something that doesn't work. Okay, let's try this one. 1 equals 3 minus 2. Oh, that one does work, doesn't it? So we'd have to go to another one. -1 equals 2 minus 2. And that does not work. Okay, so see, sometimes it's not just because the first one works. Write a rule in function notation. So again, that is your f of x notation. A car can travel 32 miles per gallon of gas. So I'm going to use G for gallon of gas. So f of G. So if I put in the number of gallons, I can figure out how many miles I go. It just looks bad. Right? Because when you multiply the number of miles times the number of gallons, you get the total amount of miles. I think this was a 1, hopefully. A lawyer will be paid 1/3 of the amount awarded in a lawsuit. Okay, so if we have f of x, they're going to get 1/3 of whatever that amount is in the lawsuit. Evaluate. So again, you got to show your work. There's 2 problems. So I'm going to go over here and do f of 2. And I'm going to put it in there. And be careful with your parentheses. So 2 times 2 raised to the second minus 1. So what's 2 times 2? It's 4 raised to the second minus 1. 4 to the second is 16 minus 1. So 4 to the second equals 15. All right, good. Then you got to repeat it over here. So f of -1 equals 2 times -1 to the second minus 1. So f of -1 equals 2 times -1 is -2 to the second minus 1. -2 to the second is -2 times -2, which is a +4, minus 1. and that is equal to 3. Remember, you don't do anything with that side. We're looking at the right side. Good. I do independent variables now. So, both. We're doing both on this one. So we got the independent and we have the dependent. A certain movie earns $1,200 for each screen that it's shown on. Okay, so what depends on what? Everyone's getting home, sorry guys. What depends on what? So the cost depends on what? The number of screens. So that is my dependent, that is my independent. Okay, remember the dependent is usually the amount of money. So that's going to be the amount of money that they get. And the independent then is the number of screens. Okay, so when you go to 12, is this a discrete or continuous? Very good. Discrete, because I give you specific values right there. 4 of them. Okay? So you're going to set up your little XY chart. You're going to figure these 4 ones out, and you'll be good to go. Plot them and be done. You don't have to connect them because it's not continuous. So if I put in y equals absolute value of something minus 1, that's what this is. So again, I'm going to use those erasable things here. So if I put a -3 in here, y equals the absolute value of what? And the answer would be -3 minus 1 is a -4. So y is equal to what? 4. All right, let's put the -1 in there now. If I put a -1, oops, I used the wrong one. Oh well. -1 minus 1 is a -2. The absolute value is 2. Now we're going to put a 1 in there. One minus 0 is 0, and that is also 0. And lastly, we're going to put in a 3. 3 minus 1 is, I am a bit perfectionistic, aren't I? 3 minus 1 is 2. Absolute value 2 is 2. So we just need to plot those. -3, 4. It's up here. -1, 2. 1, 0. And 3, 2. Yeah, my nose is running. Thank you. Do I connect them? No, you don't. It's discrete. Move on. Oh, is this discrete or continuous? This is continuous because I don't give you values. You have to make your little XY chart and pick your own. So let's pick -1, or -2, -1, 0, 1, and 2, and see what we get. So we have y equals something squared minus 4. You put in a -2 here. Okay, what's -2 squared? I'm going to do this a little faster. That's 4. Minus 4 is 0. Okay, what if you put a -1 in here? -1 squared is 1. Minus 4 is -3. What if you put a 0 in here? 0 squared is 0. Minus 4 is -4. What if you put a 1 in there? Getting messy. 1 squared is 1. Minus 4 is -3. What if you put a 2 in there? 2 squared is 4. Minus 4 is 0. Let's plot them. -2, 0. -1, -3. 0, -4. 1, negative 3, and 2, 0. Do we connect them? Absolutely. It's continuous. And it's a parabola. This is not a V. Wow, that was a pretty good one. And I put arrows on both ends because it goes forever. All right, 3 more problems and we'll be done. Moment for my sponsor. Nothing like a good Zevia. All right. The table shows the number of employees in a company over 5 years. Draw a scatter plot and a trend line. 2 things to do. So let's plot the points first. In 01, it is 15. In 02, it is 20. In 03, it is 23. In 04, it is 30. I don't know how I can even see anything. It's so dark in here. 05 is 34. I hope I'm doing this right. I should look at the screen. It's brighter when I look at the screen. Okay. So a scatter plot, again, it's not going to be here because it's not 0, 0. In 2000 doesn't mean that they didn't have any employees. But I need to do my trend line, so it has to go in the direction of this and trying to go right kind of through the middle of the data. All the way through the graph. Don't stop. Then I can now predict. So let me grab my handy dandy green pen. Wait a minute, we don't even know if we predict. We have to scatter line, plot, move on. Based on the trend line, predict. What kind of a garbage pen is that? What is that even? Bunch of garbage. Let me get a better one out. Can never go wrong with these. These are the best pens. See? Perfect. Okay. Based on the trend, how many employees will a company have in 2008? So you go to 2008, right here. You follow that line up till it hits that other trend line. If you didn't extend the trend line, you won't hit it. Okay. Now I go back this way, try to go straight, and it's somewhere in there. So I would say it didn't quite hit 50. I'm going to put 49 for a guess. Now, yours, again, I will look at your specific trend line. So it should be in this ballpark somewhere, but again, I'll look at your trend line, and if you're going up here in this direction, not down here, not over here, not up here, it should work. Find the next 3 terms of this sequence. Okay, let's look for the 5 plus 6 plus 6. Plus 6. Our D is 6. So we got to find one here, or we don't have to find anything. We just have to add. 23 plus 6 is 29. Plus 6 is 35. Plus 6 is 41. Now find it. There we are. D. All right, now we got to use our formula, which I will have on the board. A sub n, which term are we looking for? Right here. Oops. Last one, people. We're looking for the 18th term. So A sub 18 equals A sub 1. That is your first term. Go back to your line of numbers and find the first one. It is a 2. Plus n. What was n? 18. Minus 1 times the D. Oh, we didn't figure out the D. Got to figure out the D. 2 to negative 2, that means it went down 4. So I got to make sure I put a negative 4. Down 4 and down 4. My D is a negative 4. Be very careful you don't lose your negative. So I'm going to put it in parentheses so I don't think it's a subtraction. So I have A sub 18 equals 2 plus 18 minus 1 is 17 times a negative 4. So I got to go off and do this multiplication. 17 times 4, 68. So A sub 18 equals 2 plus a negative 68. So A sub 18 is equal to a negative 66. Ding dong. All right. Very good. 20 minutes. Pretty darn good. Let me know if you need any help. Come before school. Take care. Bye.